All right, so this is going to be my first video here talking about some of the stuff I've been doing. Today we're going to be talking about what I like to call the item scroller, which is the component you see on the screen right here. I've got it pretty well working. We kind of just need to finish it up. But before I start, I'm going to go ahead and go through what the concept of this is and what we still have left to do, which is really just kind of finishing things up. Uh, Basically, the idea of the item scroller is something that is a component that allows you to scroll through data, and when it reaches towards the end of that data, it then requests the next page of data. Here, we'll go ahead and we'll showcase what I'm talking about here. I'll go ahead and kind of restart this. This is my own little testing suite using Storybook. If no one's used it before, Storybook's a really good uh, library, component runner, if you will, that lets you visually see what your components look like, what they do, allows you to run tests on them, and kind of uh, develop, without having to worry about putting it inside like an actual running application. Give you an idea of what it's doing and let you test things out. So the idea behind this is we've got a sort of a mock API that has about 5,000 randomly generated records in it, names and IDs, and it's displaying it in using checkboxes. The checkboxes don't do anything. Basically, the point of this is just to show the scrolling. So as we scroll, you'll notice the scroll bar on the right there is there. Once we hit a certain point, you'll see that there's a page request coming across and new data loads. And so that's what happens. We keep scrolling, this thing keeps loading and loading and loading. It will basically just load all the data that you have if you so wish to do that. The idea of the component is to stay as simple as possible so that basically requests go out, data comes in. We try to keep the renders down to a minimum by memoizing the data coming in. I've written my own memoize component, my own memo component that does a deep comparison on the dependencies. That way, if changes like updates to the actual data come in instead of actually modifying the array, then it will pick up those changes as well. I mention that because I'm not sure how many of you know, but React's default use memo does work with arrays, but it only works when the size of the array changes. So that's the only time the use memo will fire. So if you make a change to it, you'll want to see that data actually show up. So here we've got about we're at 7 pages now. This another thing that this does is this only renders 3 actual pages at a time. So in this case, the default page size is 50. So it will only render a maximum of 150 records. Now, when you're loading, it only renders the page you're currently on and the page above. So it's only 2 pages. But as you scroll back through up and down, it will keep 3 pages rendered at a time. The point of that is to try and stop the user from seeing the fact that basically there's only 150 records ever displayed at a time. So, for example, right now we've got 10 pages times 50 records would be 500 records, but only 150 of these actual records are actually displayed. So we can scroll very, very quickly, and you never notice that that the pages above don't have records, and that's mainly because the way I've written this. So we need to get into the code to really kind of explain how I've written this. One last really quick thing, the idea of this came from an article I read about 7 years ago from someone at Walmart Labs when the IntersectionObserver first came out, which is the main piece of web API technology that is used to write this component. So the IntersectionObserver works by when a piece of markup that is observed by the IntersectionObserver comes within the actual viewport. Usually a viewport is just the main document, but in this case, we have a scrollable div here. So whenever it comes to the div, it reports it to the observer. It tells it how much of it is within the observer by a ratio. So of course that ratio is from 0 to 1. So you can determine how much of a particular piece of markup is seen within the observer. Um, I'll get into it and then I can explain what I mean by that. So let's go ahead and jump into the code. Here is the main item scroller component. Basically, the scrolling element is the element that we actually are using. That is the scrollable div. So it doesn't create its own scrollable div. We give it the scrollable div we want to use. The data is pretty obvious. It's the data that keeps getting loaded. Page size is defaulted to 50. That can be changed. You can make it bigger. You can make it smaller. Whatever you want to do. Minimum page count. I've got a piece of documentation here, and that's about the truth. It's the minimum number of items that will be considered a page. So basically, the concept of the minimum page count is if you're going along and loading data, if you're coming from an API, you're not always going to have 50 records when you hit the end. Sometimes you might hit the end and there may only be 10 records left on the last page. Well, in that case, 10 records in a lot of cases isn't going to be enough to actually put a proper indicator in there and all that. So what it'll do is if it's less than 15, it will actually attach those last items into the previous page. So instead of that page having 50, if it's 10, for example, it'll have 60. Enclosing page count, that's how many pages are on either side of the current page you're on. As I was saying, when you're scrolling, if you're on page 3, well, page 2 and page 4 will be rendered as well. This is once again helping give the appearance that data is always loaded. We don't want the user to actually realize that not all the data is rendered. All the data is loaded, but not all the data is rendered. And the reason for this is to make this thing as fast as possible. If you have 5,000 records, well, divided by 50 records per page, that's 100 pages. You don't want to render 5,000 actual records in DOM because that's going to eventually slow down your site, especially if you have, let's just say, a drop down with a lot of records in it. And you may say that may not happen. The current client I do my work for, it happens a lot. We have many drop downs that have 2,000 or more records in there, and that's where ideas like this started coming from. Is because you can have some clients that need to have a lot of data loaded at a lot of times, and they don't just have one drop down per form. They usually have 8, 9 drop downs per form. And so we don't want to load all of the data for all of the drop downs and render all of the markup all the time. You're going to have a very slow site if you do that. So that's where something like this really comes in and is really advantageous. Class name is something you see on most React components. Just ability to set styles and things of that nature. On request page data is basically the item that's called when we reach the end of the loaded dated pages. So this doesn't get fired as you're scrolling between pages that are already loaded. This gets fired when you hit the end of a page, when you hit the indicator that's on the last page. So what we do, you'll see that we keep track of the last loaded page here, and that's how we do this. So when you reach it to where the page you're on is the last loaded page, it makes a request for the next page. And the idea is that hopefully the API comes back fast enough that you don't actually even know that it's loaded data. You just think the data just keeps growing and going. Children is basically this component is what would be referred to as a headless component. There is a small amount of markup, but there's no style to it whatsoever. And that's the concept of headless components. Headless components are almost entirely JavaScript, almost entirely, whatever. I mean, in our case, since we're doing React, it's JavaScript. But yes, they're almost entirely code, very little to no markup, and definitely no styling. So no styling. The styling is provided 100% by the consumer of the component. So that's where we are. So the way we do this is we have a concept. I'll kind of try to go through the top and try to make sense of everything that's here. Basically, the render pages state here is what tells the component which pages should be rendered. So the intersection observer, like I talked about, when it knows it's on page 2, it sends out to calculate which pages should be rendered. Well, if we're on page 2, page 1 and page 1, 2, and 3 should be rendered. That's what this is used to store. Set record modification flag. When the data is changed, you have to have some way of React causing a render. It's a simple Boolean flag that just gets flipped. That's all it really does. So that's what this is here for. Final data. This is, like I said, I memoed the data as I said at the beginning of this, and I said I use my own custom memo. This is my use deep memo. Basically, it does the same thing that use memo does, except for it actually compares the dependencies in a deep way. In other words, instead of just doing most times in React, dependencies, properties, things of that nature are compared with an object is comparison. That's all well and good when you're doing strings, when you're doing numbers, when you're doing Booleans, but as soon as you go beyond the most simple and the most primitive types, once you get into objects, once you get into arrays, those comparisons don't work as you think they would. Like I said, if you make a modification to an array in React and you pass it in, but all it is just a modification to one of the items of data, but not a modification to the actual size of the array, it won't fire. Nothing will happen. It'll just continue to go on thinking nothing's happened. So that's where the deep memo comes in. The deep memo comes in because it has to actually do line by line comparisons, property by property comparisons and things like that. Now, that can be very slow. So what I've done is I am using, to do my comparisons, I'm using a library known as fast deep equals. Now, fast deep equals is quite fast. If you look at the lodash is equals library, lodash is equals runs at about 220,000 operations per second. And that may sound good, but trust me, lodash is equals is probably one of the slowest is equals deep, deep equals libraries out there. Fast deep equals in comparison does about 776,000 operations per second. And the tests that they were using to do that, they used differently shaped objects as their test. So anyone that knows anything about JavaScript performance realizes that means that it's truly that's truly an actual speed test, because there really is no JavaScript performance. So that's 776,000 operations per second without JavaScript performance coming in. So that's pretty quick. I haven't noticed. I was last weekend I was loading 5,000 records in here, and I made a change at the top. Fast deep equals goes from the back to the front. That's how it works. It's another way it goes fast. JavaScript has this weird thing that if you go in reverse order, it actually goes faster than if you go from the beginning of an array down to the bottom. It's just one of those things. So to test it, I actually made a change at the very top of the array, and it was almost instantaneous. So it's still pretty quick. Now I'm going to do a lot more tests before I say it's done. But yeah, that's pretty quick by my standards. These are all just the different variables here. Maintaining what the current page is, how many total actual pages there are currently. That is not calculated each render time. Hence, it's a useref. It's calculated only when new data loads. Current page is calculated each time that we switch to a page. Last fulfilled page. This is the one I was talking about that tells us if we're on the last page. So this is the last page where we made a request and we got data back for it. So when current page is equal to last fulfilled page, we request a new page. Next page index. This guy right here is basically how I divide up and I decide where I'm going to put the indicator to request the next page. Previously, in another component, I put it at the very end, and that's all well and good. But the problem is, you have to scroll to the end, wait for the API request to come back, wait for the data comes back. The idea behind this always was that we should do this to where the data comes back before you even hit the bottom. That's the idea. You don't even know that the data is there. The average user will just be scrolling along, and probably not ever even notice that there's an API request happening each time they scroll down the page, which is the idea. The idea is to make the user unaware of what really is taking place, but to do something really, really convenient and helpful for the end user, for the actual developer using the component. Loaded data is just the data that has been loaded. So yeah, then we got the calculated render pages. Now this, each time the data actually loads, so each time there's new data loaded, what we do is we divide up the render pages. Now, And I did a previous component similar to this one. It was more complicated than this one, but similar to this one. And what I was doing is I was calculating the pages and then never recalculating them. So each time you got the data, it would just render the pages. So when we had to go and take out data, well, we'd go out and we'd remove a record, move 2 or 3. And what would happen is now that page, instead of having 50 records, has 47 records. Well, it doesn't seem like it's that bad, but imagine going through and deleting 20 of them. Well, now you have a page that has 30 records. Now it starts acting wonky. It starts acting funny. It loads at different places. It kind of jumps around a little bit. It doesn't look as good. So each time new data comes in, the render pages are reloaded. This also helps us when we're removing things, when we're adding things, stuff like that. But we only do it once. And the reason we only do it once is because the calculations and the ways that we do it. If we do it in the actual render cycle, which I was doing initially, it is so slow. It's almost impossible to. It doesn't work well. The render is slow. You can actually watch the render happen. It's one of those kinds of things. Page heights. Now, the way we make the actual bar look the size that it does is whether or not there's data loaded. The one thing that always stays loaded is the actual div that is the page that's containing data. And so when data is not loaded into there, the shell of the page is still loaded, but it's set to the height. And you'll see here, the next things we talk about we'll explain how we do the page heights. The intersection observer is the part that I talked about earlier, where basically the page and the actual marker, that is the get next data marker, both are observed by the intersection observer. So each page and each next data marker is observed, and as they come into view, we're alerted by it. We're told, hey, this is in the view, and here's how much it's currently in view. The resize observer is what does the page heights. So each time that a new page is created, a call goes out. The request for it's a call to the children property. That's what this is right here. So it calls out and it sends the data that is for this page, and then it asks the user to go ahead and render that data, and then it sends it back to us. So when that happens, obviously the page height itself changes to adjust to whatever the actual rendered components are, whatever the rendered markup is. And that's what the resize observer is used for, is to catch the page heights. Resize observer is much more performant than doing window.resize, or on resize in JavaScript. On resize fires, every little itty bitty change that happens, it fires, and it's highly inaccurate. Now you can throttle on resize and all that, but resize observer does all that for you. What it does is the same thing. It basically waits until all of the resizing is done, until all the different adjustments that happen while all the things are coming in, and while the browser's doing all of the resizing of the main page component. It waits until that's done and then sends you the updated information. So it's much more efficient, much more basically much more efficient. So that's why resize observer is used. I think we can all know what unique ID is for, just because we're gonna have more than one of these it's highly likely that this can be used on a form more than one time. So it's always good to make sure you have your unique IDs in your React components. Let's see here. So yes, here we're creating the resize observer, calling the resize callback when the component gets destroyed. So I'm not sure how many of you know everything about React. I'm sure if you've worked with any React functional components before, you've seen that how empty dependency array use effects work. Basically, this runs one time at startup. This here runs upon destroy. So basically, we're creating the resize observer here because we only ever need it once. We don't need to recreate it because we're not linking to a new piece of markup. We're just linking to the ability to catch resizes, and then we just connect both of them as we go away, because we don't want to have data hanging around, RAM hanging around afterwards, and end up causing browser crashes and all that kind of stuff. So we've got a use effect on the page size. This is the next page index, which I talked about a little while ago, how we're calculating where we need to place that, that next page indicator at. That's how this is calculated, page size. I found that initially I did it at 75% of the actual page size, but I found that that was having some issues. I'm willing to bet it had to do with the multiple calls to the intersection observer. I think they were happening too quickly, and things weren't firing off as fast as they needed to. So basically, I went ahead and I put it there at about 60%. That seems to have fixed all the problems. I can scroll pretty quickly, and the data still gets loaded. So let's see here. The next thing is final data. Now, final data, as I said, is my own use memo that I did. So each time the data property gets changed, final data renders the use memo fires, and basically then this guy picks it up, because then the actual reference to it then changes, as memo does, and then we determine what's happening. Now, the first time final data comes through, if it isn't loaded with data, that's the else condition here is hit, and it basically requests the data. If we have data, whether the component is started off with data, or if we have made the request and now we've come back with the data, then it hits inside of here. Basically, if there is data, and the data actually has a length that's greater than 0, then we check to see if this is the condition that will hit most of the time. Most of the time, the reason we have data changing is because we've scrolled down and we've loaded new data. This is the easiest and most common one, like I said, and the fastest one too from our use memo standpoint, because one of the first things that fast deep equals checks is array size length. If they're different, it immediately fires back that it's not equal, and then it goes down the path. So that is definitely our fastest point of what's happening and all that. So basically, like I said, we load the data, calculate the pages, calculate the render pages. We'll be going through these functions really quickly, so I'm not going to go into them now. Calculate the render page data, sorry, and then calculate the render pages, which is the actual pages that are going to be rendered. And then we just increment the last fulfilled page. So if we were on page 1, last fulfilled page starts at 0, if I remember right. I'm not going to go back up and look. I'm sure I am. And so then if page 1 has been requested, basically we will increment page 1. Now, I think I just caught a minor bug. If we start off loading data, although maybe it wouldn't be a bug. If we start off loading data, it would say the last fulfilled page is 1. But if we did, that's true. If we loaded a lot of data up front, which is why I did it this way, so I can load a large swath of data up front if I want to and have it divided up into the different pages, then this would be inaccurate. So this is something I'm going to have to fix. Once again, this is a work in progress. I'm trying to let you guys see how I think and see how you catch bugs and how you see those things and you try to just do what you can with them. If we do not have, if this was not caused by basically new data loading, then there's a good chance that there was an update. There was an update. Even delete will still hit in here, because delete changes the page size. So the only time we hit in here is if we actually end up strictly updating data but not changing the actual size of the array. So basically then we kind of just load the data, we do the recalculation of all these things just to make sure everything stays in sync, and then that's when we set the modification flag. As you see, we just flip it is all we do. So this is just a way to fire off. I'd like to do it differently, but for now it does seem to work. I've used this sort of mechanism before, so and it seems to help pretty well. You don't want to be firing things more than you have to. I'm especially in situations like this with components like this, I like this to be something that it's efficient as possible. And so in React components, the way you're as efficient as possible is you render as least as possible. That's why you see a lot more use refs in here than you do use states. State should only be used when it's absolutely necessary, and state should be used when the changing of that should cause a re-render of the component. Let's move on. Here's the scrolling element, and here's where the intersection observer happens. So when the new scrolling element is passed in, a new intersection observer is created, passing the root of the scrolling element. So that's how you tell the intersection observer what it needs to be observing. What the main root it's observing. Once again, we've got the return here that disconnects it, making sure that we don't create multiple instances of the intersection observer that never get destroyed. And right underneath there is the actual callback for the intersection observer. I'll do that so I can actually want to see where this is. Let's see here. So actually, I moved this over to the stuff I was doing last night and found something I can do to be more accurate with this. We pick up all of the intersecting entries. Entries have intersection observer entries have a property called isIntersecting. And what that is that gets set to true when it's actually visible, when at least a small part of it is visible within the actual observed element, in the root element in this case, as you've seen. Basically, you can also set how much an item needs to intersect before it fires. So the way I've set it is as soon as even a pixel of it is intersecting, it ends up in the intersection observer. But if I saw that was causing too many problems, I could set it at a higher rate, and you can set a series of them. You can have it be one, or you can have it be an array of different intersecting values. They all need to be in a basic percentage. It's between 0 and 1. So if you wanted to do it at every quarter part of the page, you could do 0.25. I think it would be 0.25, 0.5, 0.75, and 1, and that would fire only when it reaches a certain amount of intersecting. In our case, since our viewable size won't be very big, I think the most we ever see intersecting here is maybe like 0.15 or something like that. So you're not really going to have any advantage to doing stuff like that. But if you are doing it on a much larger page where you're using the intersection observer, then that may not be a bad thing to go ahead and try to implement. So in here, hopefully we'll take a look at this really quickly. Basically, the main page here is the actual page wrapper. I was talking about where the data is loaded. This is how we determine which page you're currently on. As you see, basically what we do is we take any pages that are currently intersecting, which when you're moving between two different pages, you're going to have two different intersecting values. So as the page is moved, basically what happens is we sort between the intersecting ratios. So whichever one has the greater intersecting ratio is the page that is the current visible page. So if we're about halfway, it'll figure out by the intersecting ratio which actual page we're on. If we have an intersecting page, that's what this guy does, then basically it tries to determine what currently is happening. If the main page number is not the current page number, then we go ahead and set whatever the main page number is, and we recalculate the render page. This is where I was talking about where the intersection observer decides how the render pages need to be calculated. The next part is the request data marker. The request data marker is the other marker I told you about. That is actually just what it is. It's just a 0 pixel div. It's full width, but it's 0 pixel. You don't even see it, but it does get picked up by the intersection observer, and that's what this guy is. If we run across the request data marker, then we pick that up. We take the last fulfilled page, we add 1 to it, and we kick it back out and ask the user for the next page. So not a lot of code, which is really nice. Intersection Observer does a lot of the really difficult work for us and just gives us what we need. So very, very nice web API to use, and yeah, pretty invaluable in my opinion. Resize callback is the callback for the resize observer. Basically the same thing. Anything that resizes in here, any piece of DOM that we're observing that resizes gets kicked through here each time the resize finishes. And so basically what we're doing is we're trying to keep the page height the same. So like I said, so the scroll bar doesn't go up and down. The scroll bar stays the same even when the data is not loaded. We set it into our page heights here, which is just a record. It's a record or record number. So the page and the height. And so that's used in the actual page component. We pass it to the page component when it doesn't have data rendered. When the data is rendered, we obviously don't set the height, because if perhaps something happens this time on a render and the page height changes, we don't want to have that page height set. We want whatever the user's doing to decide the page height. And then when that does happen, we will go ahead and we'll reassign the page height if that happens to change. And honestly, I probably shouldn't. I'm not even sure I should have that now that I'm looking at that, because if it does go to 0, should we save it? I don't know. Probably wouldn't happen, but I don't know. It's, yet again, many things that I have to go through. Calculate render page indices. So this is basically giving us the begin. Yeah, it is. It's the, oh, that's right. Okay, so this is what's used to slice the data. So yeah, we take the current data length, we take the page, we multiply it, we take the page -1 times the page size as the begin index. So that gives us the beginning count of the previous page, or where the previous page left off. The end index, then this calculation, as you see, is a little bit more complicated, and that takes into account the whole concept that I told you about with possibly including other data on there. I know it may not be there. Maybe in the calculate. Yeah, the calculate render pages does that, doesn't it? Yeah, something like that does it. I need to test that out to see if that part's actually there. But yeah, basically the end index then just uses the current page we're on, the total page. If we have total pages, basically it takes the page size and says if it's less than the data length. Okay, this is what takes the yeah, that calculation into effect, basically. So yeah, if the total length, basically, if the total data length here is less than the page times the page size, then basically we just assign it to the page times the page size. Else we just assign it to the the page times the page size plus the data length divided by the page size. So basically, it's taking anything, any little remnants, and assigning them back to the end index, so we can make sure we slice the data correctly. Calculate render page data. This is what I was talking about, where it actually does the slicing. So this goes through all of the pages each time the data is changed, and it actually slices up the data. So here's the render page, basically. Each render page is just calculated like this. Honestly, I could have made that a 1 and not had to do this. I probably will. I'll probably change it to a 1 and this to a less than or equal to, so I don't have to do a separate addition here. And then, yeah, just slices up the data, puts it in there. Like I said, as these things are rendered, if the data hasn't changed, there's no reason to have to constantly reslice the data each render. It's just it's too slow. So we want already pre-sliced data to go ahead and be part of that render, and that's what this is doing. This is making things more efficient by only slicing the data up when something actually changes in the data. Okay, so now we've got calculate render pages. This is what actually calculates the pages that get rendered. So, like I said, if you're on page 3, it calculates the calculated render pages calculate page that you should be viewing, page 2, 3, and 4. And you'll see that here. The start page says it's the current page minus the enclosing page count. So if you're on 3, that would put the start page at 2, as we see. We got to make sure that's greater than or equal to 1. If it is greater than or equal to 1, then we go ahead and do it. If not, we just set it to 1. So if we're only on 1, then the start page will be 1. And then the end page is whatever the current page is, plus the enclosing page count, which is defaulted to 1. If that is less than or equal to the total pages, then we do that. If not, then it's just the total pages. So yes, if we've got to the point where we're on the last page, we don't want to set a render page to a page that doesn't exist. And so then basically we just kind of loop through here, add it to the pages array. We determine what the start page is. If the start and end page, if we only have a single page, then there's only one page to be rendered. So it only pushes this is one of the few hard codings you'll find here. And that's because if we're on the first page, we should only render the first page. Well, and the page's dot length is equal to 0. So basically, this is when it initially loads before any other data is loaded. Right. And so if not, if we're not on the start page 1, then if we say the start page is greater than 1, basically this does all the does all the different calculations. So we take the pages that were added and we potentially slice them off, basically making sure that we don't put pages that don't exist. So that's what this whole calculation here is for. If we don't hit either of these conditions, that's why they're if else if, then the pages just go as is. So basically, the 3 pages that we put in here up here, these are just to make sure that we don't put pages that don't exist. Let's see here, and then we set the render pages. So this is the state setting here. Boom, we're done. Let's see here. Calculate total page count. Pretty basic. Total data divided by page size. If it comes out that ends up with 0, we assign full pages to 1, and then basically just return the page size. So either we return whatever the full pages calculation was, or if the page size is not greater, okay, this is where the minimum page count comes in, and this is where the minimum page count comes in, and that's I knew it was used somewhere. Okay, this is where the minimum page count comes in, and how the total page count is determined. So if the ending page size basically doesn't have a size that's greater than the minimum page count, then we just go ahead and assign the full pages. Basically, we make sure to assign it to that page. If not, then we go ahead and we make sure that we add 1 to the end of it. So there you go. Render pages markup. This is kind of the workhorse of the application. This is the whole rendering part. And you'll see below when I actually do the return, we're almost to the bottom of this. You'll see below when I do the return that basically it calls this. So this is all the work. So basically everything we've done before is used here. So we go through all the potential pages, all the total pages, and just sort of loop through. If it's a render page, you'll see below that the render pages is what gets passed as the parameter here. That's how we determine if it's a render page. If it's a render page, the data is rendered. If it's not, the page is still rendered. The height is assigned. You'll see that the height here is only assigned when it's not a render page. So when this is not one of the pages that has data, then it goes ahead and grabs that page height that was saved and puts it here and passes it to the component. So the component still maintains its height, but there's no data in there. So you're saving a lot of DOM rendering there. Pretty basic. If it is a render page, you render. This is where the next page index comes in. So you've got the top part of the data, the bottom part of the data. That then allows us to put the scroller page marker in here, and that's what gets caught by the intersection observer to request the next page. So that's sort of how we're doing this whole thing. It's pretty basic. That's it. We do that and we return the final markup. As you see, setting up scrollable div, setting up basically a scrollable div here. Well, yeah, it's setting up to where it can be scrolled. It's not the scrollable part, but this is the part that can be scrolled. Because the actual part, yeah, is called when we do the children render. Oh, which was above. Yeah, we saw that above. And so yeah, basically here, if we have render pages, then we go ahead and we pass it to render page markup, and it's done. Plain and simple. Scroller page component is pretty basic. It's just the wrapper. Here's the wrapper part that wraps around the data, and the data that's passed to it, it just renders. It doesn't do much. We do need to break this out. I noticed that I did this and I didn't break these out individually because the intersection observer and the resize observer can change independently. This still needs to be here for when the entire component gets destroyed, but also if the intersection or resize observer change at any point, which is possible, then we need to go ahead and destroy them individually and recreate them as well. So yeah, when the page element's created, basically, as long as if there was a previously observed page, so if the page is being recreated, basically, then we unobserve the page from the resize and intersection observers and then reobserve here, and then we assign that element back to the observed page. Therefore, if it gets done again, we'll be able to unobserve. Once again, this is trying to stop us from having problems with memory, where basically we just have orphaned instances that sit out there forever until the browser crashes, which is not the experience we want for our customers. So pretty basic. The scroller page marker is even simpler. It fits on a single page here, as you can see. All that's needed is the intersection observer. We don't care about the size because it's always a 0-pixel div, like I said. Pretty basic. Got the intersection observer here when the actual element is created. That's all it does. Just fires the element that's created. Once again, same concept. If it had one previously, we unobserve it, and then we make sure to reobserve it and assign it back. Both of those are very simplistic. I'm probably going to memorize these because they will get called more times than they will be created. I'm not sure how many of you know about memoing components, but you basically do it to stop unneeded renders. And the page component definitely needs to be memoed because from the time a page is created until the component is destroyed, that page will more than likely always exist. So memoing it is good because the changes will be minimum, and then that'll stop a large number of renders each time things scroll. So that's a very good thing. You've got to be careful though. You don't want to overuse memo. You don't want to use memo on everything, because especially components that their properties change a lot, you're kind of defeating the purpose. If something's going to render quite regularly, there's no purpose in incurring the extra cost of the memo if you're not saving renders. Only use memo when you can really save renders, basically. So that's pretty much it. Now, I spent quite a while. Hopefully next one I do, I'll be starting from scratch, so you really will be coding with me. But I really wanted to explain this one because this is quite a complex component. It's definitely outside of the simplistic side of React components. The next one I'll be doing will probably be I'm going to be converting all my current components to part headless components. So I'm going to be breaking out the logic into a headless component. We're going to have a library of headless components, and then BSoft components will use those headless components as its own thing. The nice thing about headless components, and especially creating headless components, will be that it makes you think in kind of a separate way. It's kind of the way MVC works. MVC makes you think about the controller logic aside from the view logic. So basically, that's what headless components will do for us. It'll make us think about the logic of the component up front, and then think about the actual view components of the view parts of the components. So hopefully in the end, what we will get is more performant and better written components. Anyways, let's take a look. I really don't know exactly what we have left to do here. Let's take a look at what we got. So yeah, it's just render trigger. So yeah. Okay, so it didn't really fire much. One thing I did say I wanted to change here was the intersection callback. I saw this in the other scroller I did, that we were getting a lot of intersection entries fired where there were entries coming across, but none of them were intersecting. So this was coming back as an empty array, yet it was still running through all of this. There's no reason to be running all of these. I'm not a huge fan of JavaScript, methods, like using the JavaScript array methods. But since this doesn't need to be, since this thing only runs, on a very short number of actual items, you're not really going to see much of a performance improvement by going to straight for loops. But one of the nice things to do would be, say, and this actually cleaned that up too, if intersecting entries dot length. Now I'm wondering if anyone can tell me why that works. And I will tell you here in just a second how that works. Those of you that have been JavaScript devs for a long time will know how that works, know why that works. But this is referred to as a truthy or falsy statement. Basically, length is a number, and JavaScript treats numbers as truthy falsy statements. Basically what this is saying is if length is greater than 0, then you'll come inside of here. So that's how JavaScript works. If in a number, if it's a number, if it's 0, 0 is false. Everything else, everything above 0 is true. Actually, I don't know on negatives. I'm sorry. Never really. I would guess negatives are also false, but I don't want to make that statement without looking it up. I haven't really had to look it up in a while. But yeah, basically what this will do is as long as there are intersecting entries, then we will run this code. If not, if we just happen to have entries that aren't intersecting firing in here, then it'll just jump out and not do anything. There's no reason to run through all of this and come up with nothing happening. So that will solve that problem. Not really a problem, but it'll make it more efficient. What else do we got here? I'm going to try to keep this to about 15 more minutes. This was put in here because I had an issue in the use deep memo. I've got another library called bsoft common that I try to put my common hooks, functions, and anything that I'm going to use in potentially other places. Since bsoft components isn't the only library I'm going to be working on, I started breaking things out and kind of using them to where they can be reusable. Also, then if others want to see it, and if it's like some of the components, some of the pieces I have there, they can use it themselves. So yeah. The issue I found was basically when it was doing the comparison, the first comparison seemed to work, but what I did is I also wrote my own deep clone function as well. I'm basically trying to get rid of Lodash. There's only a couple of Lodash methods I was using inside of here, but Lodash is very slow in most cases. Don't get me wrong, it's very thorough, but it's also very slow. And so I'm writing my own because it's not like I don't know how to do this, and I'm one of those people that just likes to make sure that I know that everything is as fast as it can be for me. And so, and yes, I know in saying that I used fast deep equals, but I've been through the code. It's only about 67 lines of code. It's probably one of the most efficient things I've ever seen. So that's why I used it. And I actually went through the code line by line and made sure that I agreed with most everything it's doing. There are a couple things that I would do differently, but overall, it's pretty good library, and it's definitely fast. So that's why I used it. Let's see here. What else do we got? We've got that. Oh yeah, I said I was going to do this in the page marker. Right, I even put a note for myself here. So basically we need to add a use effect for each of these. So use effect, we'll do it on the intersection observer. So basically we say if observed page dot current, oops, mistyped there. Then we say intersection observer dot unobserve. Wait a minute, no, that's not what I'm trying to do. I've already got the intersection observer dot unobserve. That's not what I'm trying to do. What I did want to do here is this. Yeah, this is what I wanted to do. Then you say intersection observer dot disconnect. So yeah, basically that's what this would do. I'm going to make sure it's right before yeah, that's what I want to do. Basically, you want to do it over. No. Yeah, that's not correct. That would actually cause a bug. That's not what I meant to do. What I did mean to do is say if observe page dot current, and that would have adverse effects. But we would see it very quickly when we ran Storybook. Hence, yet another really good reason to have something like Storybook. You catch a lot of things pretty early on if you make a mistake in it. So we've got the observed page.current. Now, yes, this could be written differently. Even, I guess one might say more efficiently in JavaScript. You could say observed page.current double ampersand and then run this. It's the same thing. I like to be a little bit more explicit because younger devs may not understand that that's a valid if check in JavaScript. Uh, so yeah, you could say observed element.current right here, ampersand ampersand, and then this, and it would work exactly the same way. But so anyone wants to call me out on that, I prefer to be a little bit more direct with how I do things, so people don't get confused. Basically, that didn't do the autocomplete part. Okay, let's see here. So yeah, when resize observer changes. No, that's not right, is it? That's not right. Eh, okay, I'm gonna have to think about that because as I'm thinking about this here, that's not really right. That's not really right because when the intersection observer changes, we wouldn't be unobserving because the intersection observer changes. Yeah. Okay. I'll leave the comment there, and I'll come back when I'm not under the gun of recording this here. If you guys want to see what becomes the end result, I'll probably have it checked in by this weekend, so you can definitely take a look at it. But yeah, I'm still gonna keep that because I'm pretty sure that needs to be done. Just I'm not fully thinking right now about how that should work. This is overall done. I think that's working pretty quick. Yeah, like I said, let's get it shot. Oh, by the way, for anyone wondering, I use Bun as my runner. Bun's a pretty new library out there, but it's fast. This is Bun with Storybook 8, and it's got the plugin for Chromatic. I have a Chromatic account as well. Um, as soon as this kicks off here, I'll show you. Boom. I mean, it's already there. It is. It's already back up. I don't know how many of you run Storybook before, but when I run it with Yarn, and I'm using Storybook 7 at work, and I run it with Yarn, I'm sitting here for another good 20, 30 seconds at least for it to start up. So Bun is just amazingly fast, and it's even faster with Storybook 8. So, I mean, Storybook 8, I still could switch over to the terminal and still see it running. Since Storybook 8, though, super, super fast. And this is what I was talking about when I talk about Chromatic. So you can actually, if you push this button here, it's a plugin you can add to Storybook 8. And I think it was available in Storybook 7 too, just so everyone knows. But if you push this here, this will actually deploy what you currently have to Chromatic, which is really nice because that way, previously what I had to do is I would create draft PRs to get my Chromatic build happening first. I'm not sure how many of you understand how Chromatic works, but you have to set a baseline before you make your changes. So it's really good to have this to set your baseline for you so that then you get real changes. Because what'll happen a lot of times, we use Storybook at work, and I say we deploy Storybook at work. We don't really use it all that much because it always shows all the components are changed, and that's because we're not using it correctly. Basically, we're not creating a build on Chromatic early on, and then it sees our changes. So it just says everything's changed because the first time we build is the first time we create a PR that we're about ready to deploy. So any changes are only going to be the minor changes that happen after the initial build. So yeah, it looks like it doesn't work correctly, but you have to know how Chromatic works. And I've got to say thank you to the Storybook and Chromatic people because they actually explained that to me, and they also helped me get this whole thing running because this is using Vite. And there was an issue with the Storybook Vite compiler and Chromatic when I ran it in GitHub Actions. So it wasn't a problem with any of that. It was the combination of all of those things. You know, the Chromatic deployment action in my own Chromatic action, yeah, and they spent like probably 3 or 4 weeks back and forth of just trying things, telling me try this, try that, and they went through the whole team. Great guys out there, really good, and did a really good job. So let's see if we can, as you see, here it is picking up. The delay you see there is done by me. I actually put about a 1 second timeout between the request and the delay to try to imitate an actual, what would actually be an API call. If you look to the right there, you'll see that as it's going, it just sort of jumps up. You'll be running. Next thing you know, boop, kind of just bounces, and it bounces because new data has been added to the form. Now here, I'm going to try to get a decent amount of data and show you the speed I'm talking about here of this thing, because we're getting close to the hour time limit. I really do not want to keep anyone longer. I don't want people to say, Brandon, you're way too long. You talk too much, because I do talk too much. But here, we'll get a decent amount of data. Like I said, 5,000. It's about 50 pages. Yeah, it's 50 pages worth of data. I don't want to get all of it. There's 15. That's a decent size of data here. So decent amount of data in here, and we're going to change the fourth record right here. We'll have my name on it instead of this name. And of course it doesn't work. Of course it didn't work. Well, it had 750 records in there. That's something I got to look at. So I did make some changes before. This was going to be a test to see if those changes broke anything, and it did break things. Once again, I'm not gonna keep anyone any longer. It should have changed. Yeah, right here. That should have put my name right there. It obviously did do it, but it didn't update. So I've got to dig in and figure out what's going on. But I'm gonna leave you guys here. And like I said, if you want to see the end result, you can check. Uh, when I post a video, I'll post the link to my GitHub account, and you can take a look. There aren't many branches out there, so it'll be easy to find. It'll be named Item Scroller, so just look for that one. And you can see the end result of how I fixed that issue. So let's end there, and hopefully you learned at least a little something, and I hope you watch again. So that's it for me.